Previously, we looked at the problems that are in the most simple settings, so we don't need to worry about the uncertainties that will happen in the future. But now we are ready to come to this point that to incorporate the uncertainties that may happen in the future. Now let's look at a problem with a simpler setting of these uncertainties. Now let's look at this example problem with considering of the discrete random variables. Just a recap of the discrete random variables. You may have learned that from a statistical course, which means the random variable can take any specified accountable list of values. Let me show you an example below. Say we have flipped a coin, we have a head, or we can have a tail. If we have an unfair coin, then we will have 50% of getting a head and 50% of getting a tail. And we have both of these condition cases add up with the probability to 1. Now let me use a more abstract example here. So let's say X is some type of event that will happen from a set which contains event A and B and C. And let's for simplicity, let's just say event A, B, and C are independent. And then the probability that A will happen will be 10%, and probability of B that will happen is 30%, and probability of C that will happen is 60%. And since these A, B, and C are all the possible events that may happen for X, so we add up those probabilities that will sum up to 1. And we say that X here is discrete random variable since X is taking a discrete value from the set we have here, so it's A or B or C. Now let's look at this problem on the left. For this problem, we want to know whether it is worthy to install the new ski lift that will recover our initial capital investment within 5 years. To solve this, what we want to know is the net present value of all the future benefits and all the costs. However, in this problem, we will have uncertainties for the future benefits and costs. That depend on how many days of skiing weather will happen in the future. So to really get the net present value, we need to incorporate all of these uncertainties in the future. In this context, we have 3 kind of events for the future. There is a 60% of probability of having 80 days per year of skiing weather, and 30% of getting 100 days of skiing weather, and 10% of getting 120 days of skiing weather. Now let's calculate the net annual profit case by case. So the first case, and for case 1, we have on the profit part, we have 500 people, and each person will cost $10 and for 80 days. And then the cost part will be the maintenance, the annual maintenance, that's $1,500 per day, and we have 80 days, and we get the annual net profit is 28 and 0,000. And in their similar pattern, we calculate annual net profit for the second case. So we have the first part for the first 80 days. During the 100 days, we'll still have the same benefit or profit from 500 people and $10 and 80 days. Then because we have 100 days, which means there are 20 additional days that are available, the lift will be used by only 400 people per day during the extra period. So let's calculate additional 20 days profit. So there are about 400 people with $10 per person and 20 days. So that is the additional benefit. That is the benefit for the additional 20 days. Then we minus the maintenance cost, which is $1,500 per day, and that's 100 days. And we will have 33,10,000. And for the third case, we are following a similar pattern, and that's copying down first. So the first 100 days, and we have got from the previous stages. So let me put these numbers down for the first 80 days. And from day 81 to day 100. And we want to use the extra piece of information. If 20 more days of skiing are available, only 300 people per day will use lift during those days. So what we have on day from day 101 to 120 will be 300 people, so $10 and 20 days. And minus the maintenance costs, that's 1,500 and with 120 days. And we will have 360,000. So now we have all the annual net profit ready for all three cases. And we want to do for the next is to unify or combine all these information together. And the technique we're going to use is called expected annual net profit. In this context, that is the probability of a certain case times the annual net profit from that case. And we sum off all these cases up. So we have case 1 to 3. And that's what we want. Now let's drop down the numbers. So for the first case, we have the probability of 0.6, and the associated annual net profit is 280,000. And for the second case, that's 0.3 probability, and with the annual net profit, that's 330,000. And the third case, that's with probability of 0.1 and the associated ANP, which is 360,000, and we get 303,000. Since we want to know whether our capital investment will recover within 5 years, and then we want to further convert all the annual net profit back to the present worth. Since we are using the expected annual net profit, so we call the thing we want to calculate is the expected present worth. So we have the initial capital investment, that's 900,000. Since that's cost, and then we put a negative sign there. And the second piece, we want to convert the expected annual net profit to the present worth. So we give the annual expected net profit 303,000 and take that to the present worth, so a given P, and 25% in 5 years. And then we have minus 85,142, which is less than 0. So we know we cannot recover within 5 years. And we conclude by not recommend to install. And we are done.